So this is going to pick up right where we left off if you have your stuff open. All right, so what we did is we created and just to remind everyone what we did, just to kind of make things easy, I created a whole worksheet called pivot tables. And to do this one, we went into the ARDS full tab at the bottom, the worksheet. And I selected, you got to have a whole rectangle that you put into pivot tables. So I just selected the furthest one on the left. We needed to have, where is it? Membership. So I selected membership. No, I went too far. Sorry. I got to find satisfaction. Okay, I selected satisfaction. So M1, and then I came down to membership because these are the two that we need for this hypothesis, right? So I came down to the bottom of membership and I made a whole pivot table using this rectangle of data. And there's going to be a bunch of variables in here we don't need. This is just a quicker way to do it, because if not, you got to like cut and paste those two columns and put them next to each other and make a rectangle.
Just satisfied.
Yeah, so we got to sit there and then we go to insert and we're going to go to pivot table. And then if you haven't done it before, you're going to put in a new worksheet. I already had another worksheet, so I selected where I wanted it. Okay, now here is, I'll build this all over again. So let me get everything out of here. Let's build this all over again. Okay, so we got our template. So over here in the pivot table fields are all these variables that we just picked in that rectangle. So we're going to take, and we're going to, what we want is membership for our rows. So scroll down over here in this little window and find membership and drag it down to rows. Okay. So if you do that, you'll see over here you have bronze, gold, none, and silver. Okay. So we can put this in order. I'm going to put none at the top. So I select none, wait till I see that 4-pointed arrow, and then drag it up. And then I'm going to do the same thing with silver. I'm going to stick it between bronze and gold and put it up there. All right, so I go now. Remember, this variable is categorical, but it's ordinal. There's an order to it because it depends on how much people were spending. All right, so I put it in the right order now. Now I'm going to make a contingency table because I want to know what proportion chose very satisfied. So I'm going to come over here to this where I have all the variables I can choose from. I'm going to find satisfaction and I'm going to pull that into the columns. All right, so we did that. All right, so the thing about this order is if I was trying to do something fancier here, I would care about the order here because this also is ordered, right? We can definitely put an order to satisfaction from the people who really don't like organic food superstores to all the people who love it, right? So we're able to do that. But for our purposes, for this hypothesis test, the order doesn't matter because all we want is the proportion that are very satisfied. So does anyone remember how do we get the number in this table? So right now we have the rows and columns set up. How do we make the number in there be the proportion? How do we start? We can drag down, because we have clean data, we can drag down any variable we want, but it might just make sense to drag down satisfaction. So it's going to count how many rows of data. So I'm dragging this down to values. Okay. So now when you look at this table, what we care about is very satisfied. That's the only one we care about. So 21 out of 117. Now you can get your calculator out and do that proportion, right? Or for gold, we have 11 out of 36. This is 11 divided by 36 is the P1 bar, and 21 divided by 117 is the P2 bar. So that's our sample data observed. We're observed, it's observed in the data for sample proportions. But we can do this, have Excel do that math for us, so you don't have to put it in your calculator. The other advantage of having Excel do it for you is there's like a audit trail is kind of one way to call it. Like you you can show someone how you got it. You can do it on your calculator, and it vanishes. Okay, so let's see how do we change these numbers to be proportions. And by the way, there's many ways we can do this. So you want to be really clear on which one you need to do. But before I do that, I'm going to copy this down here. We started to do that last week. Okay. So let's go ahead and copy that table down so we can keep track of our totals. So I'm selecting that table. I'm going to copy it. And I'm just going to paste it with special values. So you don't actually get the pivot table. You just get the values down here. Oops, I don't know what I did. All right, here we go. All right, so just to clean it up, this is kind of where we're at. This is what the only thing we care about from this is going to be the grand total that are bronze. So I'm just going to highlight this so you kind of get your eyes focused on this. This is all we're going to care about from this table is the grand totals. Okay, so notice that my value field settings disappeared. How do I bring them back? Does anyone know how you bring them back? You just click somewhere on that pivot table and they come back. Okay, it's like you activate the pivot table. All right, so how do we change this so that we can get the proportion of bronze in our subpopulation of bronze? We want to know the proportion that are very satisfied. Does anyone remember the functionality in the pivot table that we have to go to? You want to go down to this little thing, and there's a bunch of stuff hidden in here. So you're going to click on this drop down, and you're going to go to this value field settings. Okay, that value field settings is your friend. Okay, it's going to make life a lot easier for you. So you go in there and you see show value as, and right now it says no calculation. It's just counting how many records fit that the row and column categories. So right now it's not doing a proportion. How do we convert that to proportion? Here are the choices. So you can do percentage of grand total. You can do percentage of column total, percentage of row total, percentage of blank. I think that lets us fill it in, and percentage of parent row total, whatever. So there's some variations that you can do here. Which one do we need? So if this was an exam question or you were presented to it, which one would you use? What's the one that we want to use? Actually, let me move this box out of the way so you can actually see the data better. Maybe it won't let me. Oh yeah, well, okay. Which one do we want to use? So think about it. What's our subpopulation? What are our two subpopulations? Bronze and gold. And we want to know the proportion that are very satisfied. So what we want to do is divide by this total over here, right? So we want to know what is the percentage that the 21 is. Sorry, you can't see what I'm pointing to. You want to see the percentage that 21 is out of 117. So this is a row. So we're going to divide by the percentage of the row total. Okay. So let's go ahead and pick that one. We'll say, okay, so now everything got converted for us, right? And if you don't believe it, you can test it on your calculator. You can say, what's 21 divided by 117? So let's try that. Equals 21 divided by the 117. And that says it's 17.9. So yeah, so it's given it to us correctly. All right, so it's doing it for us, which is great. So now I'm going to copy this because I don't want this to get changed. Anything that's still in the pivot table could change. So we want to just kind of freeze it. It's like we're taking a photo of it, like a screenshot in a sense. Okay, so now we got this here. It converted all to decimals. That's fine. All right, so let's go back over to where we were doing hypothesis tests on Tuesday. And we were, as soon as that bar moves, I can scroll over. Maybe I can get over here. Okay, so we were in the second example on the 2 group one. And what we were looking at was the situation where we had row 1 minus row 2 is less than or equal to 0, or row 1 minus row 2 is greater than 0. We had these conditions for use. We needed n1 times p bar 1 to be greater than or equal to 5, and then n2 times p bar 2 to be greater than or equal to 5. And I could have put a question mark on the end of these, because what we really want to know is this true? And by the way, this is information and material you need for task 3 or exam 3, or for you guys is the final. All right, so this is not exam 2 material, but like I said, I need to teach ahead so that you guys can actually do the work for test. Keep up with it. All right, so let's get in here and write, we have the gold membership. And for that, we're gonna need N1, so the sample size of gold, and P bar 1. Then we're gonna have the bronze, and we're gonna need the sample size of the bronze and P bar 2. I'm gonna open up another window and arrange it next to it. Hopefully it'll arrange it for me. All right, so I'm opening the pivot table. I'm opening the pivot table on the left. Sorry, yeah, on the left. So here's the pivot table we were just working with. Actually, I need to make it a little wider. And then here's our hypothesis test we're working to fill in values. All right, so we got gold. And bronze, right? Okay, so for N1, that's just the sample size. So all I'm gonna say is I can come over here to gold and I can copy this 36, or I can point to it. I can say equals the cell that has a 36, done. And for N2, that's the number that are bronze. So I'm gonna say equals and point to the cell over here that has the bronze. All right. You guys good with how I did that? Okay, now let's get the proportion that are gold. So for the proportion that are gold that actually chose very satisfied, I'm going to do the same thing. I'm going to come over here, and here's the proportion that are gold. I'm going to come over to very satisfied. It says 30.56%. Right, and then for the proportion that are bronze, I'm going to come up here to that 17.95%. Okay. All right, so now I pulled everything I need out of the pivot table. So now I'm going to make the pivot table a little smaller. So let me make this table bigger now. All right, so now this is where we're at. Let's go ahead and put this formula in here. So N1 times P bar 1. So this is equal to N1 times P bar 1. And we get 11. And remember I said, if you want, you can get fancy and have Excel decide if this is greater than or equal to 5. You just say, is 11 greater than or equal to 5? And it says true. And then let's do the same thing for the second subpopulation, the bronze folks. And we're going to say is N2 times the proportion that are very satisfied that are bronze members. Is that greater than or equal to 5? Let's copy that. Okay, so they both need to be true. Can we use this test? And so the answer is if these, so and is going to test two things. If this is true, comma, and this is true, then we'll say yes. Otherwise, we're going to say no. And again, this is a little bit bells and whistles. I just want to show you how you set something up to be a template so that you can reuse it for other new data. If you set it up as a template, it's going to automatically give you answers. All right, so now that we did that, we're good to go. We're going to need the test statistic. Oh, sorry. We need to get the standard error for the test statistic. So in order to know what we're doing, so on this sheet, you guys got your sheet out? Look on the back side on the, well, on the side that says 2 group tests. And it's a second from the bottom. we're going to be looking at the difference between proportions. And in here, we're going to be building. So we've already confirmed we can use this. So now we know that the test statistic will follow a standard normal. So the test statistic is going to be the P1 bar minus the P2 bar. And the difference in that is the expected value, which comes from the right-hand side of the hypothesis test on the null hypothesis, and that was 0. So we just dropped that, right? It's had a -0. We talked about that on Tuesday. And then we have to put the standard error in the denominator. And the standard error is on this sheet, and it's this weird, crazy equation that I told you I'll program and upload this to Brightspace so you don't have to do all the programming on this. Okay, but let's go through it, and right now, I'll go ahead and do this. We need to get the standard error, so we need the pooled proportion, which is called PP on this sheet. And so in order to do that, I'm just going to say that's going to equal, and the numerator is P1 bar times N1. I'll put my glasses on. Plus P2 bar times N2. You guys keep me honest here. Don't let me make any typos. Divided by N1 plus N2. All right, so I got 0.209. Did anyone try it? Okay, so now the standard error is going to be equal to the square root. And I'm looking on there and it says PP times 1 minus PP times, looks like 1 over N1. 1 divided by N1 plus 1 divided by N2. All right, and then closing off the square root. All right, so I got the standard error to be 0.07514. Is anyone keeping up with me trying to do it?
How do you
Okay.
know which one to use?
Yeah. How did I know which one? Oh, because we are in the difference between
Okay.
proportions. So this is what I
Then
just
this is
now
what we
programmed.
need.
Yep. Any other questions? You guys okay? Yeah. Oh, over the PP, yeah. It's on the sheet, the standard error formula here. Do you see it? It's second from the bottom on the 2 group tests under standard error. You see it? Little PP equals. So now that we got that, we're all set. We can start putting together the test statistic. So let's do the test statistic. And that's going to be just what I wrote on the board right up here. So I'm just going to go, this is going to equal, in the numerator, it's P1 bar minus P2 bar, P bar 2, sorry. And then I'm going to divide by the standard error, which is in this cell right here. So if I do all that, I get 1.6264 for my Z-score. Okay. Oh, I forgot to remind you guys, we always use the alternative to determine if it's a left-handed test, right-handed test, or two-sided test, two-tailed test. What is this one? It's right tail. How do we easily know that?
Since we're using the alternative, like the sign is pointing to the right.
Yeah, if you look at the alternative, exactly what Lily just said, if you guys couldn't hear her, you look at the alternative, it's which way that inequality points. It's pointing to the right, so it's a right tail test. Okay, so if it's a right tail test, what does that mean? Let me remind you guys. Where is my? Oh, so what does that mean if it's a right tail test? Well, it means this is going to follow a normal distribution, and we're going to have some value here. We expect it, if we do our math right and everything's right, because it's a right tail test, we expect that test statistic to be way out here in the tail somewhere on the positive side, right? Because it's a right tail test. So this comes out to 1.0 what was it, 626? And so what we need to know is what's the probability out here? This follows a normal distribution. Excel won't just give us that. Excel won't give us that. So what do we have to do to get that? So this area under the curve is what we refer to as the p-value, right? Remember this? And how do we get the p-value when it's to the right? We use that idea that the area under the whole thing is equal to 1. So this p-value is equal to 1, which is the area under the whole thing, minus the area that's to the left. Right? So that's minus the norm S distribution with the 1.6, whatever that number is, and true, because we want a cumulative distribution. So that's the 1 minus with everything to the left, right? So that's what we're going to do to get the p-value. So I guess I'll put it right here so we can see it all on the one screen. Oops. And so this is going to equal 1 minus the norm.S distribution. We're going to point to that test statistic, Z, and we're going to say true. All right, so I get a p-value of 0.05-ish. Okay, so right under this is where we write in our alpha. And our alpha was 0.1. And then remember I told you, you can, if we've programmed in the hypothesis test and the decision already, we can just copy it. I don't think that one's going to work. Let me go to one that I think will work. I think this one will work. The reason I say it just has to be formatted the same in the Excel spreadsheet. So let's go over here and put that right here. Okay, and let's check if this is pointing to the right cells. Yes. So the hypothesis test is checking that the p-value is less than the alpha. And if that's true, the decision says, if that's true, then reject the null. If not, do not reject the null. Okay. All right, so we did all that. So now we can write our conclusion. And what I told you is, by the way, is everybody good with what I just did with this hypothesis test stuff? You're following along, tracking? Yeah.
Can you just hover on the true?
Yeah. So the true is actually test. This is when we finally get the test. And remember, all hypothesis tests come down to this question: is the p-value less than the alpha? If that's true, you reject the null. What we're saying is the probability of seeing this is so far away. Remember, this is if what we're seeing, if the truth, the null hypothesis is true, we should have a high probability of seeing, and from our sample, something close to the null, which would bring us in a z-score close to 0. So what we're seeing is something that has low probability of happening if the null is true. Therefore, we reject the null. We say the null, we don't believe the null is true. That's the logic of hypothesis testing. That kind of makes people feel like their head's sick. But you just got to get it straight. That's why I recommend kind of programming it. That way you're like, okay, I don't want to go crazy in the middle of like a stressful situation. Like my boss is like, what? Where does this go? Like, no, I got it. Okay, so if that's true, then what I programmed here is I just point to that cell and I say, with that, if whatever comes out in that cell is true, then I'm going to reject the null. If not, I do not reject it. Okay, so the conclusion now, that is, and we always start the conclusion with stating the significance at the 10%, at a significant, actually, let me start again, at a significance level of 10%, there is enough evidence to accept that gold members have a higher proportion of very satisfied than bronze members. Okay, so we thought we saw something in the data, but just by looking at point estimates, you might be wrong. You have to include the variability around that to really make a statistical statement. Okay, that's you can kind of count on will hold water beyond just this sample. Okay, all right. Any questions on that so far? Okay, then the last one I want to show you is what is called a paired t-test. So the last example comes under something called a paired t-test. And for a paired t-test, what we're talking about is you have the same data. So two measurements on same entity. So by entity, it could be a dog, it could be a field, it could be a person, because you have two measurements. So for example, blood pressure before and after a medical treatment. All right. So in a case like this, we want to know your basic format for the data is think of this as a new variable, the difference in the two measurements. Okay, so given x1 and x2, so you're measuring two different things, might be batting average at the beginning and end of the season. Let D be the difference. Okay, so like you look at the difference between those two, and then proceed as a single mean test. So basically, we want to say something about the difference. So our test statistic. So let me just remind you, so you say something about the difference, this D, sorry, you're going to say something about the average on the difference. And it's either not equal to or less than or greater than, right, 0, or the null is that it's equal to or greater than or equal to or less than or equal to 0. Okay. So all we're doing is, before we couldn't pair them up. They might have come from different people. Now we know they come from the same person. So we're actually just looking at the difference, and we're going to then treat that as a whole new variable and run a single mean test on it. All right, so this is our new mean. So this is looking exactly, this is going to follow a student's t distribution. With degrees of freedom n-1. So again, everything is the same as on your sheet, your handout, for a single mean test. Okay. It's also on here for a paired t-test, but if you look at them, they're identical. Okay, they're mathematically identical. And so the test statistic is equal to the difference that you see in your sample minus the 0, or some people refer to this as the expected value. You could actually be testing for an actual number difference. That's more rare. And then we're going to put this over the standard deviation of this variable over the square root of n, which is the standard error. This is just standard error. That's what I told you. The same formula happens over and over and over again. Okay. So I'm just going to do an example of that. So if you look on here in Excel, if you look on that form, if there is a paired t-test in Excel, so that's great. It makes it really easy and quick to do. So let's consider spending in, so this is example 3. spending in 2021, and we'll consider that as variable X1. And we're going to want to compare that with spending in 2020. And we're going to think of that as variable X2. Okay, and we want to know, is it possible that there's a difference between these? I mean, do we believe that spending in 2021 was greater? Okay, so what we're going to do is we're going to define D to equal X1 minus X2. And we think, because of where that's coming from, that we want to test in the alternative, is D greater than 0? In other words, with spending, so let me put that in English, test, is spending in 2021 more than spending in 2020. All right, so that's the alternative that we put in here. So we want to know, is this difference greater than 0? And the null is the opposite. Is it less than or equal to 0? All right, so we're going to test this, let's say, at an alpha of 1%. All right, so let's go in and do that real quick. This one's a kind of a quick and easy one to do if you want to check stuff like this. So let's go into our hypothesis test worksheet. So pair t-test is fairly straightforward to do. So if we go in here, let's set it up in our hypothesis test worksheet. I'm going to come over and put a vertical line in. And we'll put 3, example 3. We have H naught and H alternative. The alternative, then null hypothesis is that D is less than or equal to 0. The alternative is that D is greater than 0. Okay, so one of the things we need to do right off the bat, and let me give myself a little more space here to work here, is we want to identify, if based on the alternative hypothesis, what kind of test is this? So once again, which direction is the inequality pointing? We want to know, we want to use the alternative to decide if this test is going to be a right-tailed or left-tailed. And what you look at is that inequality, and it's pointing. See, it points that way because it goes like that. Okay, so that's right-tailed, right? All right, so that's actually all that we have to do. Now we can set this whole thing up. And what we're going to do to set it up is we're going to come over here to the data. So go back over to where your data is, ARDS, and go up to this data tab. And in the data analysis, we're going to pop that open. And we're going to scroll down to where you have the t-test paired to sample for means. Okay, and once we open that, you want to find the one that says paired to sample for means. We're going to put the V1 range is going to be our spending in 2021. And our second variables range is going to be the spending in 2020. And our hypothesized mean difference, remember that's coming from that null hypothesis. It's the number on the right side, right over here. Up on the null, it's a 0. So the hypothesized mean difference is 0. We do have labels in our data. The alpha was 0.01 or 1%. And the output range, I'm going to select it to be right here. Okay, and that's it. We ran it. That was much quicker than the last time. All right, so let's look at what we got as output. What this is saying is it's giving us the average spending in 2021 and the average spending in 2020, the variance, the observations. It gives us the correlation coefficient. Notice it's around 0.2. That's pretty weak. If it was higher, it would mean people who spent a lot in 2020 tended to spend a lot in 2021. Because this is weak, it seems like it doesn't matter. Some people spent more in 2020 and less in 2021. and vice versa. Okay, so now that we know that, the key thing though is the important information we want out of this table is just one thing, and that's the p-value. So where's the p-value? Because it's a right-tailed test, we're going to go to the one-tailed statement right here, okay? If it was a two-tailed test, we would use this probability. Remember, the p-value is a probability. So for one-tailed test, the p-value is this 5 times 10 to the negative 54. So it's very small because look at our t-statistic, it's 22. So when you're thinking about a standard normal, which a t-distribution is close to, you're talking way out here, 22. So it's very little area under that curve out there. So let's highlight these two, just so you're clear that this is the p-value because it's a right-tailed test. All right, now I'm going to type in my alpha. My alpha is 0.01, and I'm going to go ahead and copy over the formula that does all the hard thinking for me. So I'm going to copy this formula over. It's going to tell me whether the p-value is less than the alpha or not, but I got to check it, make sure it's pointing to the right place. Okay, right now it's comparing an empty box. The blue is on an empty cell. So I got to drag that up here to the p-value. So let's go ahead and drag that box on up. And now this is testing if the blue box is less than the red box. Answer, true. Decision, reject the null. Okay? So what we can now write in our conclusion, we go right to the alternative. Conclusion. And we're going to say, at a significance level of 1%, what? Can someone tell me? How would you word it? How would you word the conclusion in plain English? I'll start it. On average, OFS customers, what? What's the alternative that we've sort of accepted now? We've sort of ran this test and we have the alternative.
Spend more in 2021 than 2020.
Perfect. You get a +1 for that. On your final your final average for the whole semester. All right. So on average, on average, I was spent. It's actually past tense, right? Spent more in 2021 than in 2020. Okay. So that's it for all the different kinds of uses for hypothesis tests and how we do them in Excel.